So magnetic induction due to a circular loop is given by the formula B is equal to mu naught I R square by 2 into R square plus Z square whole power 3 by 2. So when radius of the loop is very small compared to the distance, this R can be neglected. So when it gets neglected, then you will have B is equal to mu naught I into R square by 2 into Z cube. So this expression gives the magnetic induction due to a circular loop. When you consider at the center of the loop, at its center, so at center we will have, at center means this Z becomes 0. So at that time we will have B is equal to mu naught I into R square by 2 R cube. So this 2 gets cancelled. So we will have B is equal to mu naught I by 2R. This is the magnetic induction at the center of the loop. So instead of loop, if we have coil means it will have more number of turns. For n-turn coil, so for n-turn coil, magnetic induction at its center is given by mu naught I by 2R into N. So magnetic induction due to a coil of wire is given by mu naught Ni by 2R. So this is magnetic induction due to a circular coil. Next we are going to see tangent galvanometer. So tangent galvanometer is a device which is used to detect flow of current in an electrical circuit. So tangent galvanometer is a moving magnet type galvanometer. It is based on the principle of tangent law. So what does this tangent law states? Tangent law states that when a magnetic needle or a magnet suspended between two crossed magnetic fields, the needle or the magnet will come and rest in the direction of the resultant of the two fields. So we are having two magnetic fields. So one is B, another one is BH. For example, if we are having two magnetic fields, if a magnetic needle is suspended in this crossed fields, this magnetic needle will come and rest in the resultant of the two fields. So let this magnetic needle comes and rest, makes an angle theta with the vertical field. Therefore, from tangent law we will have B by BH is equal to tan theta, or B is equal to BH tan theta. So in tangent galvanometer we are having a magnetic needle. That magnetic needle is placed between two crossed magnetic fields, so that the magnetic needle will come and rest in the direction of the resultant of the two fields. Now let us see the construction of tangent galvanometer. In construction, a tangent galvanometer is having a circular coil. This circular coil is wound over non-magnetic frame like wood or any non-magnetic material. This coil is having three different types of turns. One is usually the tangent galvanometer, what we are using in laboratory, is having three sections of coil. One is having 2 turns, another one is having 5 turns, and another section is having 50 turns. Each section of coil is connected separately to the binding terminals. So this circular coil is fixed vertically to a rotating round table. So this is a rotating round table This table is having 3 leveling screws. So the 3 leveling screws is used to level the circular table so that the table is perfectly horizontal. So we are having a rotating turntable. This rotating turntable is having 3 leveling screws. By adjusting these 3 leveling screws, we can make the table to be horizontal. When the table is horizontal, the coil will be vertical. This coil is having 3 sections, as I told already. Each section is connected to different binding terminals. So we are having 2-turn coil, 5-turn coil and 50-turn coil of different thickness, and they are used to measure currents of different value. At the center of the turntable, this turntable can be rotated about an vertical axis passing through the center. At the center of the rotating table, we are having a upright projection. This upright projection carries a magnetic compass. At the center of the magnetic compass, we are having magnetic needle, pivoted magnetic needle. This pivoted magnetic needle moves over a graduated scale. The scale is divided into 4 quadrants. Each quadrant reads from 0 to 90. A long aluminium pointer is connected to this magnetic needle. So from the position of the magnetic needle or from the position of the aluminium pointer, we can measure to what angle that magnetic needle gets rotated. So the center of the coil and the magnetic needle coincides with each other. So this is the construction of tangent galvanometer. So tangent galvanometer, regarding its construction, it is having 3 main parts. One is circular coil, second one is rotating round table, third one is magnetic compass box. So these are the 3 main parts. Coil is having 3 sections, 2-turn, 5-turn, 50-turn. It is wound over a non-magnetic material. It is kept vertical on a rotating round table provided with 3 leveling screws. The leveling screws are adjusted to make the round table to be horizontal. When the round table is horizontal, the coil is vertical. At the center of the round table, there is upright projection, a pillar-like projection which carries a magnetic compass box. It is having a pivoted magnetic needle at its center. This magnetic needle moves over a graduated scale. The scale is divided into 4 quadrants. Each quadrant reads from 0 to 90. To this magnetic needle, a long aluminium pointer is connected perpendicular to the magnetic needle. So when magnetic needle moves over the graduated scale, this aluminium pointer will also move over the graduated scale. From the position of the aluminium pointer, we can read out to what angle the magnetic needle gets deflected. In order to avoid parallax error, a small mirror is fixed to the below the magnetic needle. This is the construction of tangent galvanometer. Now we are going to see how this tangent galvanometer works. So it works on the principle of tangent law. So in order to obey tangent law, we need 2 magnetic fields but which is acting perpendicular to each other. In tangent galvanometer, one magnetic field is produced by passing current through the coil, and the other magnetic field is nothing but the horizontal component of Earth's magnetic field. So in order to produce magnetic, horizontal component of Earth's magnetic field is acting along north and south. So the magnetic field produced by passing current through the coil must act along east and west. So in order to produce magnetic field to act along east and west, the plane of the coil must be parallel to the magnetic meridian. So what are the initial adjustments we have to do so that the tangent galvanometer obeys Ohm's law? Initially, all the magnetic materials must be removed from the tangent galvanometer. So no magnetic material must be kept very near to the tangent galvanometer. Secondly, the leveling screws must be adjusted so that the plane of the coil is vertical to the plane of the turntable. Third one is the vertical table is rotated so that the plane of the coil is along magnetic meridian, along north and south. So when the plane of the coil is along magnetic meridian, and if you allow the current to pass through the coil, then what will happen? This coil will produce magnetic field along east and west. Along east and west. So the plane of the coil must always be kept parallel to the magnetic meridian. This is the third one. Fourth one, rotating round table must be rotated vertically so that aluminium pointer measures 0, 0 before current is passed through the coil. So before passing current through the coil, you have to rotate the rotating round table in such a way that the aluminium pointer reads 0, 0. So these are the adjustments what we have to do before doing the experiment. Now we are going to see the theory of tangent galvanometer. So making all the preliminary adjustments in the tangent galvanometer, if we allow the current to pass through the galvanometer, then what will happen? This magnetic needle will be acted upon by two magnetic fields, and this magnetic needle will come and rest in the resultant of the two fields, which makes an angle theta with the horizontal component of Earth's magnetic field. At that time, this equation gets satisfied. So, B is equal to BH tan theta. So, what is P? B is the magnetic field produced by the coil in the tangent galvanometer. So, the magnetic field produced by a coil at its center is given by the formula mu naught Ni by 2R. So mu naught Ni by 2R is equal to BH tan theta. Therefore, BH is equal to mu naught N by 2R into I by tan theta. So, using this expression, you can find what is the value of the horizontal component of Earth's magnetic induction at the laboratory. So, in tangent galvanometer, we are using in the laboratory to determine what is the horizontal component of Earth's magnetic field or Earth's magnetic induction. And it is given by the formula BH is equal to mu naught Ni by 2R into I by tan theta. This is how a tangent galvanometer is used to determine horizontal component of Earth's magnetic induction at a place or in a laboratory by doing experiment. You have to determine I by tan theta. This experiment can be repeated by passing different amount of current, and it will give different values of theta. So the mean value, when it is substituted in this expression, you can determine the horizontal component of Earth's magnetic induction.